Okay, Paul, I have a question for you.
Okay.
So these two balls right here.
Okay.
Freak. I mean, this one's bigger, but whatever. So if I drop these in, check out what happens.
Okay.
Zoom in on the camera. Is that transparent? Perfect. Oh, check it. What's this ball right here sinks, and the blue ball stays up float, stays up top.
Okay.
Explain to me why this is.
Well, I guess since the one that sinks must be heavier, and so it sinks down, and I guess the one floating is lighter, so it floats.
Very good.
But
This brings us to the topic of buoyancy. So buoyancy, we kind of took this from Wikipedia, so it looks pretty good though. Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object. And that brings us to the topic of Archimedes' principle, which states the following. Upward buoyant force that is exerted on a body immersed in fluid is equal to the weight of the fluid that the body displaces. So essentially, these balls, when they drop in this water, displaces a certain fluid. That fluid, which is the water, the mass of that fluid is going to push up against the balls. But because this ball is more dense than the fluid, it has a greater weight, and weight is another type of a force. So the force of this object is going to be greater than the fluid, hence it's going to go down.
We have this ketchup packet. What do you think is going to happen if I drop it into the water?
the whole ketchup packet, or just
a drop of the ketchup?
You get it. I think it'll sink. Maybe.
And it does, because Dustin explained buoyancy, right?
It's
So
less
we have
buoyant.
this ketchup packet with floating.
Say because there's air in the packet.
Okay, good. What would happen if you squeeze the water bottle really tight? Try it.
It's gonna explode.
That's what I would think. Really tight.
Yeah.
Whoa.
Oh. It didn't explode.
Why did it sink?
No kidding.
Now let it go and see what happens. Try squeezing it from the bottom. Maybe that'll make it explode. Still goes down.
It still sinks.
Why do you think that is?
Something to do with pressure, I would assume. From pushing in on the bottle, you're increasing the pressure inside, but why does it increase the pressure? Like, why does it push it down from here?
I guess Dustin taught us that when something's more dense, it'll sink. But I don't know why it.
Why it would.
Why
So
would it sink from that?
you said earlier that there was air in the packet, right? So when you compress the water bottle, you compress the packet, and therefore compressing the air. When the air gets compressed, it becomes more dense, letting the ketchup sink when you squeeze it.
Oh.
And then when you let go, the air expands and lets the ketchup packet flow.
That's cool.
Wow.
That's awesome.